In question 1 we have data on the motion of a car as it stops at traffic lights. We have some axes to complete to plot a graph. Well, first we need to label the axes, so we can have the y-axis as speed, not forgetting the units, the x-axis as time, again with units. Then we need a sensible scale which will fill the axes. So here we can have 5, 10, 15 meters per second, and this needs to go up to 3.5 seconds, so I'll take it to 4 seconds. Then we carefully plot the points, and the line comes out something like this. In B part 1 we need to state and explain what feature of the graph shows that the deceleration is uniform. Well, the line showing the deceleration, this part of the line, is straight and therefore has a constant gradient. And it is the gradient of a speed-time graph that gives the deceleration. In part 2 we need to use the graph to find the distance travelled by the car after the lights turned red to when it stopped. Well, this is when the lights turned red, and this is when it stopped, and the distance travelled is given by the area under the line, the area under here. This is made up of this rectangle, which is half a second in width and 15 meters per second in length, plus this triangle, which is half base times height. The base here is from half a second to 3.5 seconds, therefore 3 seconds, and a height of 15 meters per second. This gives a distance travelled of 30 meters.